Hey, my name's Brandon, and I'm going to take you through our final project for CSCI580. Before we begin, here's all of us that contributed to the project. Now, you might be familiar with Super Mario Bros. It's a really cool old NES game that was quite popular. You need to get Mario over all these obstacles and enemies so he can get to the next level. What you're seeing now isn't actually a human playing. This is an AI we wrote over the past 2 weeks. In this AI, Mario actually learns about the game as he plays. This process is called neuroevolution. Now, neuroevolution works very similarly to biological evolution, except in this we're evolving a program, not an organism. Each Mario you see here is as a result of that program. Every Mario has a brain that tells him how to play the game. This brain is called a neural network. Now, neural networks are modeled after our own human brains that use concepts similar to axons and dendrites. It works simply by taking some sequence of inputs and provides an output, or you could call it a reaction to some input. This process works very similarly to how you would actually play Mario. You look at the screen, and based on that input, you decide an action, which is you pressing some button on the controller. Now, the important thing about this neural network is that the relationship between the input and output is based on a large number of variables that we can control. If those variables change, Mario will react differently. So right here you can see that Mario jumps over this pipe. This is because the neural network has correlated this pipe being in this particular spot with hitting the A button. Anytime Mario sees this exact situation, he'll jump. However, if we just give Mario a random brain, there's a low chance that anything actually happens. The input might be that blank space up there, and that's the A button. So Mario just sits there and waits for something to move into that blank space. But nothing does, so he just sits there. Random variables don't tell Mario that he needs to go right or jump at a certain time. So this is where a genetic algorithm comes into play, or as you know it, evolution. To start with, we make a very large number of random Marios. They each have their own randomized brain. Now we take these Marios and we just let them run wild on the program. Mostly getting runs like this, or this, or this. But eventually, one of the Marios might decide to hit right on the controller. Each Mario's run of the game is evaluated with something called fitness. For our example, we based it off of how far the screen has moved to the right. Further right means he did a better job and is therefore more fit. Now the Marios that didn't do so well, those that are unfit, are killed off. We get rid of them. After this process, we're left with a very small number of Marios that did kind of okay. And this is where we evolve them. Now I said earlier that Mario's brain is filled with a bunch of variables. Well, these variables are akin to Mario's genes. The genes ultimately determine how well Mario did. So if he did well, he's got some good genes in there. Now, since we killed off a bunch of Mario programs, we need to make some new ones. And just like evolution, we decide to breed the surviving Marios because they were most fit. We take each surviving Mario and breed it with another survivor. We combine these genes into a new child, whose brain has the characteristics of both parents. And to prevent the gene pool from getting stale, we introduce some mutations into the child's new genes. The mutation has the probability to flip one or more of the child's genes into something completely different. Again, similar to what happens in evolution. If we repeat this process, well, a lot, you begin to see Mario actually learning things. The longer it runs, the further Mario begins to get through the level. Now, our algorithm isn't perfect. It is randomly based, so it's not entirely certain how far he'll get for any given amount of time. Mario's also really bad at waiting, or stopping. Because his fitness goes higher, the further he gets to the right, Mario thinks that that's all that matters. If Mario had the choice between going a little bit to the right, or going backwards and then getting even further right, Mario would pick the first option every time. And this is because our fitness evaluation is one that's very greedy, which gets Mario into some tough spots, like here. This spot is about how far Mario got. He didn't really get past this. Something about those Goombas just get him every time. Now, the fitness doesn't have to be what we picked. There's lots of research done on different fitnesses and crazy fitness evaluations out there, but we're keeping it simple for now. We've made a lot of changes to the genetic algorithm in fitness evaluations since then, and we're actually planning on keeping up the work so that Mario can finally get through the level. But ultimately, anything we do is still based on this core concept of neuroevolution. Some side notes: that small map you see in the upper left-hand corner is what our Mario is seeing. That grid of blocks right there is passed into Mario's brain as his input, and as you can see on the right there, that's the output that comes out of the neural network. And as you can see, this is fairly similar to what we humans see, just simplified for the computer's sake. This project uses Lua to interface with an emulator called BizHawk, and we use C++ for the genetic algorithm and neural network. In the description, you can also find the inspiration for this project by some people who made much, much better programs than we did. And there's also a link to our current GitHub for the project. And that's it. Thanks for your time.